Hello everyone, welcome to my next video on linked list. In this video, we will be seeing about what are linked lists and their types of linked list. Linked lists are fundamental data structure in computer science. They are used to store and organize a collection of elements in a linear manner, similar to arrays. A linked list consists of individual nodes. Let us see an illustration of what are nodes. These nodes are divided into two partitions. One partition of node consists of values and other will be carried with address. Now you can see the example. Here 1 is a value and Anderson 2 is an address of the next node. So each and every node will be carrying a address of other node. So why it is known as a linked list. This linked list will be in a traversal of single line. Let us see the next illustration to understand about it. In this linked list, you can see that 1 links to 2 and 2 links to 3 and 3 links to 4. Here head and tail are the initial elements. Head will be referencing to the first element and the tail will be referencing to a null element. Next, let us see the different types of linked lists are available. First of all, singly linked list. The singly linked list are forward traversal. Next, doubly linked list, they are forward and backward traversal. And then circularly linked list, they are circularly traversal in forward. Now circularly doubly linked list, these are forward and backward traversal. In this video, you will be seeing about singly and doubly linked list, and cyclic linked list will be on the next video.
That was easy.
The singly linked list has nodes. Each node has a reference to a next node in the list. It allows a traversal only in forward direction. You can see here 1 traverses forward to 2 and 2 traverses forward for 3 and it goes on. And kindly take a moment to observe what are the pros and cons. Let us see about the doubly linked list. These doubly linked lists are following on each nodes has reference to both on previous node and the next node in the list. This allows traversal in both forward and backward direction. Kindly pause the video to learn about pros and cons and the difference between singly linked. Now we came to know about the singly and doubly linked list basics. Now let's get started with the Java code. Previously we have stopped with array list. Today we are going to start with singly linked list. Let us create a new file. Here we are already having a tutorial 1 file. We can create a new file in it and create a new Java class. Let us name the file name as tutorial2. By doing this, we will be having a hello world Java main program. We need to rename this to singly linked list, or we can also continue with this name. Let me change the name to singly linked list so that the class name will be changed. There must be no space, so use underscore. Now the class name and the file name has been matched, so we can run the code. I will remove this hello world program. Let us start the code. Now we want to create a structure. So let us use a private class. This class must be static as it is not a dynamic programming. We will be dealing with integers, so I created an int and I will be creating nodes. These nodes will be storing the data and the address of the next node, that means the link as we discussed before. Now you might have get cleared. In node I will be passing the int data so that the node gets stored with this int data and the address of the next node. This is a function we will be using in Java to mention this. It's not having a clear definition yet now. Now the code to collect the data and save in the nodes has been ready. On the next step, we want to populate the node with some integers. So let us create a main program. It is a driver program as we discussed in arrays. If you missed the video, kindly watch it. Now let us create a linked list of populated data. For that, first we have to initial a variable for that structure. So I am naming the structure as head. The first data element is known as head, so we can pass the data into that as any integer can be passed into it. Let us select 2. Now this 2 will be stored in that node, and the another box in that node partition 2 will be empty as it is in head. We already discussed the head will be pointing towards the element and the tail will be pointing towards null in singly linked list. Now we want to add some other numbers to link with another node. Here I have added second and third as the new nodes that will be linked to head. That means head will be linked to second and second will be linked to third. How I am linking is head.next, which means that head is connected to second and second is connected to third. By this we can connect the nodes and traverse the nodes from head point. From head to tail we can traverse by this link using a while loop or for loop. Mostly in nodes we will be using while loop. As in arrays we have been using for, here we will be using while loops. Now initializing the current as head because we are going to start the traverse from the head point. While seeing the doubly linked list, you will be understanding it better. Now I'll write the system out code. In this print statement, we could get the data in a forward traversed manner. Here we are initializing the next node to be connected and to be printed till the current node is null. That means the tail will be the null element. So till tail the values will be printed. This is the linked list code of singly linked list forward traversal. Now let us try to run this code. Here the part we used, this is the main driver program. I am just summarizing everything, and only integers can be passed because we used integer. If you want to float a double value, you can change the data type. Now let us try to run. Code is building. Here you can see that 2, 4, 6, the given values have been printed in a traversed manner from 2 to 6. That means from the data 2 and then 4, then 6. Now let us try to add a new node and see that the repeated numbers will also be printed. In this, I created a 4, that means the fourth element, using a repeated number in the already present in that node, using 4. Now let us try. and we have to pass the link to the original node so that the head to tail will be managed through this linkage. We have created the link from 3rd to 4th. Now the tail is 4. That means the last element. Here you can see the result. We have got the new element. This is a small example of linked list. If you have any doubts, you can mention in the comment section, and this code will be added in the description with a link. You can see. Next we will be seeing about the doubly linked list. Now this is the previous outputs and the code of singly linked list. We can run the code here itself for doubly linked list, but I would like to rename the file as doubly linked list. The class name won't affect the code. Just for our reference, we can change the name. I'll be naming it as doubly linked list and refactoring it. Now you can see the class name has been changed everywhere. Let us remove this code. Now we need to create same as the singly linked list, but there will be minor changes in it. The same private class should be generated for node. Now as we done in the singly linked list, we will be also passing here also integers. So we need to create int data, and we want to create the node for previous and next linkage, because doubly linked list is both ways traversal, forward and backward. After initializing everything, using this keyword we can collect the data and store it inside the node. Now let us create a class for it to collect the node. As similarly we done this in singly linked list. Now we are repeating the process, but additionally we will be using previous this data. Now this dot next, the next will be null item, and even the previous will be representing to null. So the data what we are assigning for the head and tail will be stored inside the nodes. So till we reach the null, we can traverse the path and we can print the values. We need to create the driver program, and here we need to use two different paths because we might require forward or backward. It depends on the situation. We can use any path to traverse the data in the nodes. Now let us populate the node with some values, creating a variable for the struct we created. In this we can pass the integer types as we done in singly linked list. First, second, third, all are created. Now we want to link the path so that the head will be representing to first, and first will be representing second, and second will be representing third. By the way, we need to also assign that it must move previous. So first will be called previous of element is head. So when we call third element, it should show the second element, and the second element should show the first element, and first element should show the head, and head will point towards null. So while we reaching null, the previous will be stopped. By this we can say that it can move forward and previous. So I am assigning the first previous and first forward. Similarly, first next and first previous has been assigned now. Next second previous and next should be assigned. Similarly, third will also be done. At last, we pointed next and previous for each and every element. Now we can try to print it forward first. For printing forward, we are using current variable as head because from head to tail it should move. While using backward traversal, we will be using tail value. That means the last value as third. The third element will be used for traversing backwards. From tail to head will be moved. We will see it on the next function creating. Till now we have been created for forward. The same code will be for the backward also. Here we are using next. This next will link to the upcoming element of the head value. Now let us copy this and paste once again and change the name to 1 or 2. Currently, by changing this, the value we could traverse forward and backward, but now we have to use backward traversal. So I am creating a new current value and initializing it as third element. So from third to the head element it can move. Third towards the head, so I am replacing it with third. Still error, okay, it's just a warning. Now the code is ready. Creating a new line for better visuals. Now let me show that this is for backward. And we created the head value and we mentioned it. Now let us run the code. You can see the output here. You can see that both forward and backward. Here the doubly linked list where can be used is while we try to print the arrays in reverse manner, we can use this backward traversal. It works better. The values we used here, next, previous, these terms are generally used in nodes. If we want, we can change the names as upcoming or new values, like that also we can change the values. That's it for the today's video. On our next video we will be seeing about cyclic links. It is a continuation of this part, and
I'll see y'all soon.
On the next upcoming videos we will be posting our stacks and queues. Thank you for watching. Like, share and subscribe the channel for more related content.